Hello everyone, I hope you are all doing well. In this video lecture, I would like to introduce the topics present in the Unit 3. Unit 3 is all about one of the familiar and popular and very important word, indexes. As part of the Unit 3, we are going to learn introduction for the indexes and importance of the index, and how we are going to use this index as part of the text search. And we are going to learn a few of the concepts about what are the inverted indexes and the importance of the inverted indexes in a very detailed manner. As part of the Unit 3, in the indexes, we are going to cover the contents as follows. The contents we are going to cover in this video lecture as follows. The first one is index, and as part of the index we are going to know what is an index and what is the purpose of index, what is the importance of index, how effectively this index play an important role as part of this search engines. And the second concept is about index and ranking, how the index and ranking is going to play an important role, how the ranking is associated with the index as part of retrieving the documents we are going to see, and we are trying to understand few of the models. And the next topic is about abstract model of the ranking. Abstract model of the ranking. As part of this one, we are going to know about how this abstract model of the ranking is going to work and how effectively the document score is going to be generated. In the continuation of the abstract model of the ranking, the more concrete ranking model is also going to be discussed by considering one of the example and finding the document score from both the query and from the document end, and finally you are going to calculate the document score. And finally we are going to discuss about inverted index in a very detailed manner. What is an inverted index? What is the importance of this inverted index? And different examples with the inverted indexing, like what is the representation of the inverted index with the documents and the words and the words and the documents, how we are going to represent in a very detailed manner. First of all, we will discuss about the first topic. What I introduced as part of the contents is indexes. Just think of the index once. What is index? What is index? Indexes are the data structures. Indexes are the data structures. They are used for the purpose of fast searching. They are used for the purpose of fast searching. So if you see here, indexes are data structures. Now you have to understand and remind about the word data structure. What is the data structure and what is the importance of this data structure? We are simply calling an index as a data structure. Now if you see data structure, index as a data structure or indexes or the data structure. The data structure gives the particular way of storing and organizing the data. So the data structure gives the particular way of storing and organizing the data, which gives particular way of storing and organizing the data, so that you can handle the data in a efficient manner. So how we are justifying the data structures as the particular way of storing and organizing the data, so that you can handle the data in a efficient manner. Now we are going to study about one of the data structure, index, in a very detailed manner. What I am saying about indexes, so indexes are the data structure designed to make search faster. What is the importance of it? If you want to search very fast, you can go for the concept of the indexing. Let us understand the generalized example where we are working in our regular lives. If you are having the habit of reading the books, generally if you are having a textbook which consisting of nearly about 1000 pages, in that book, if you want to find a particular page immediately or the particular topic whatever you want, generally what is the procedure you will follow? Generally we followed the process of trying to find the index in the textbook. Every textbook having the index for the purpose of identifying the particular information immediately. If we identify the particular information immediately, then obviously we will go exact page very fastly. If you want to find any particular information in the textbook, you can go with the index and you can find the topic, and you can find the topic is present in the which page, immediately you can go. You may just imagine that if you do not have the index in your textbook, if I suppose to ask you a particular page in the textbook, then what you can do, you have to turn each and every page one by one and need to find the topic. It's a very difficult task. So here in both the ways you may find the particular information in the textbook, but when you can use the index, you can search the index in a very you can search the particular information in the book in a very fast manner. If you do not have the index, then it takes more time to find the particular information on the textbook. In the same way, if you understand the importance of this index in the case of the search engines, as we know that we are going to search the World Wide Web. The World Wide Web consisting of huge collection of the documents. Whenever you will be having the huge collection of the documents, if you want to identify a particular web page from the huge millions of the web pages, at the time this index will play an important role. For each and every document, if you maintain an index, then it is a very easy task for you to retrieve from the information for the search engines. So here indexes are used for the purpose of fast searching. If you want to search faster, you can go for the concept of the indexing. If you see here, for the text search, you can search videos, audios, images, everything you can search. But particularly when I am talking about the word text search has unique requirements which leads to unique data structures. So for the purpose of text search, there is a particular and unique data structures are there. That is the concept we are going to studying as part of this indexing concept. So for the text search, now if you go elaborately, you will find it what it is. The most common data structure is inverted index. Most common data structure is the inverted index. All of you please remind this name, and we are going more elaborate about this concept in further topics. Just remember about it. So the text search has the unique requirement which leads to the unique data structures. The most common data structure is inverted index. Inverted index. Now if you see some more points about it, the general name for the class of structures. So it is a general name for the class of structures, and here we are having the word inverted. Here we are having the word inverted. What is inverted? Why we are calling it as a inverted? Now if you see here, you will find very clear information here. Inverted because documents are associated with words. Documents are associated with the words rather than words associated with the documents. Rather than the words associated with the documents. You try to understand in a very detailed manner. If I am talking about text search, one of the most popular data structure we are going to use as the inverted index. We are using this word as an inverted. Why? If you raise the question, you find the answer here. Documents are associated with words rather than words with the documents. I hope if you see the textbook, in the textbook at the starting of the textbook you will be having the index. In the inverted indexes, documents are associated with the words instead of words associated with the documents. This is the statement, just remind and try to understand about it. If you try to understand the inverted index is deals with documents are associated with the words rather than the words associated with the documents. So whenever you understand in a very detailed manner, in any textbook, if you observe the starting of the textbook consisting of the index, in the index you will be having unit wise information, and according to the topics present they will be allocated the numbering. Accordingly the entire information is maintained in the textbook. If you want to open any one of the particular topic, you will go for the particular topic and you can go for the particular page. So that is the index you are following. If you see in some of the textbooks, at the end of the textbook you will be having the index like this. That is the one of the best example for the inverted index. If you observe in some of the textbooks, they will also maintain the index as follows. So if you observe here, the textbook consisting of some of the words, they are all arranged in alphabetical order. They will start with the letter A, and as they follows the dictionary order, that is followed by immediately the document numbers. For example, if it is consisting of A, so and ABC, R, if these are all the words, if A is present in 92nd and 99, 100, so these are all indicating the document numbers. So the A is present in which document, and ABC is present in 105 or 99. So these are all indicating the document numbers. Here one more example. So the words that is followed by the which document number, that is present in the which document number. This is one of the best example for the inverted indexing. When you go further, we will try to understand in a more detailed manner. So this is about the introduction for the indexes and the importance of the indexing, and as part of the text search we are using the inverted index, and we try to understand rather than the words associated with the documents are associated with the words. If you observe in this slide, the indexes and ranking, how the indexes and ranking is going to work in a coordination, and what we are trying to understand in a combination of these words. If you observe here, text search engines use a particular form of search. As part of it, you are going to finding the word ranking. We are going to find this word and going to follow the process of ranking. Here, if you try to understand it, you will get a few more details. Here, documents are retrieved. We are going to retrieve the documents in sorted order. We are going to retrieve the documents in the sorted order according to the score computing using the document representation, the query, and a ranking algorithm. Here we are going to retrieve the documents in which order? We are going to retrieve the documents in the sorted order according to the score computing. According to the score computing. How we are going to compute the score? Using the document representation, the query, and the ranking algorithm. Now, what is a reasonable abstract model for ranking? Now you have a question that what is a reasonable abstract model for ranking and what it can do. If you think about it, it enables discussion of indexes without details of the retrieval models. It enables the discussion about indexes without the details of the retrieval models. So we know that abstract, hiding of some of the details. As part of it, it just enables the discussion of the indexes without the details of the retrieval model. So here we are going to understand that as part of the documents are retrieved in sorted order according to the scores computing using the document representation, the query, and the ranking algorithm. if you can think about what is a reasonable abstract model for ranking, which is going to enable the discussion of the indexes without the details of the retrieval models, Now the next concept is all about abstract model of ranking. If you try to understand and observe some of the words present in this document, you will be able to understand in a very clear manner. Previously we just discussed what is abstract model of ranking and what it is enabling. If you observe here, this is the one of the example for the abstract model of ranking. As part of this diagram, we are able to find some of the components of this model. The components as follows. If you observe here in this abstract rank model of the ranking, this is what this portion, if you observe what it is indicating one of the document. It is indicating the one of the document in the web, that consisting of some of the textual information like Fred's tropical fish shop is the best place to find tropical fish at low. So this is the text present in the document, and here from the document you will be followed two arrows that is representing two types of the features. They are topical features and another one is the quality features. One is the topical features and another one is the quality features. So whenever you observe the topical features, what the topical features is indicating and the quality features is indicating. It is indicating about the subject related to the document, so that is what the topical features, and the quality features are indicating that the quality of the documents. And if you observe here, this is the ranking function, and here you are able to find the query. So that's what the tropical fish you are going to give from this document, and the query you are going to find the document score. You are going to calculate the document score. So here, as part of this abstract model of ranking, you are able to find some of the components of the abstract model of ranking or documents, features, queries, the retrieval function, and document scores. When we go in details of this abstract model of the ranking, we will have the clear idea about what is the abstract model of the ranking and what it is giving in a detailed manner. Now if you see here, abstract model of the ranking, the first, if you observe this entire diagram, in this diagram, if you are able to find, I already told you, on the left side of the figure is having sample document. It is the sample document. Documents are written in natural languages. Obviously we know that these documents and the documents present in the World Wide Web are written in generally natural languages, natural human languages. And here if you observe, it is very difficult for the computers to understand the natural languages, so which are difficult for the computers to analyze directly. What are, so the documents are written in natural human languages. They are very difficult for the computers to understand. They are very difficult to the computers to understand and analyze directly. So what it is going to do, so the text is transformed. Now the text is transformed into the index terms or document features. If you observe here, so there are so many documents are available in the World Wide Web. This is the one of the sample document you are able to observe, and what it is going to do, and it is having, and it is written in the natural human language, which is understandable by the human beings. It is a difficult task for the computer to understand that language. That's why this natural language is going to convert the text into the index terms or the features. That is going to be converted into the index terms or the features, or we can simply call it as the document features. And what is document feature? What is a document feature? A document feature is some attribute of the document It is the attribute of the document. It is some of the attribute of the document. We can express numerically. How we are going to express the document features? We are going to express the document features numerically. If you observe here, some of the numerical values are assigned. They are able to express as the numerical features. As part of this one, we are trying to understand, this is the document which is written in natural language, human natural language, natural human language, and index terms or the document features. It is a difficult task. So here document feature is some attribute of the document we can express numerically. So here the document features are expressed numerically. And if you go into more details of this abstract ranking of the model, as part of it, just now we covered the sample document and the document features and different types of the features. If you observe here, there are two kinds of the features are available. There are two kinds of the features. On top, we have the features, topical features. On the top, we will be having the topical features, which estimates the degree to which the document is about a particular subject. The document is about a particular subject. So the topical features are indicating, these are all representing the specific document about the particular subject, the document subject. And on the bottom of the figure, we see two possible document quality features. We are having two more document quality features are here. What are the two more quality features? One is incoming links, and the next one is days since last update. So we see two possible document quality features. One feature is number of web pages that link to this document. How many number of web pages are linked to this document, that is indicating the incoming links. And the next, another is the number of days since this page was last updated. So how many days back this page has updated is indicated with the days since last update, the days since last update, when it is updated last. And these features do not address whether the document is good topical match for the query, but they addresses its quality, but they do address its quality. So if you observe, these features address whether the document is good topical match for a query. If we go further details about this one, we try to understand a page with no incoming links that has not edited in years is probably a poor match for any query. You can understand that if you search for any query, if you are able to retrieve the documents from the World Wide Web, we will be having the scoring computation for the each and document. This will be done. If you understand that some of the documents available on the web are they didn't update it frequently, that's why they are not the probably a poor match for any query, right? And here each of these features, what are the feature values we will be having? There are two features are there. One is the quality features and another one is the topical features. Each of these feature values, so each and every feature is having a numerical value. They will be expressed in the numerical values. These feature values is generated using a feature function. So these values are generated majorly using the feature function, which is just a mathematical expression. So the feature function is simply a mathematical expression that generates numbers from document text, that generates the numbers from the document text. If you observe here, on the right hand side of the figure, you will be having on the right hand side of the figure, we see a cloud representing ranking function. We'll be having cloud representing the ranking function. If you observe the cloud representing ranking function, the ranking function takes the data from the document, features combined with the query and produces a score. And what it is going to do here, if you observe on the right hand side, you will see the cloud representation, the ranking function, cloud representation ranking function. The ranking function takes the data from the document features. It is going to combine with the query and produces the score, Here it is going to generate the score from the features and also with the query. And if you observe the final output, what the final output is indicating, the final output of the ranking function is a score. The final output of the ranking function is score. So that's what the score here you are able to understand, which we assume is some real number, which we are assuming it as some real number. So that may be any one of the real value you are able to find. Now if you understand, you are going to generate the score, and on that basis what you are going to decide. If your document gets a high score, this means that the system thinks that document is a good match for the query. The system will think that that will be the good match for the query. Whereas lower numbers means that the system thinks that the document is a poor match, for that query. So here you are trying to understand that whenever you are searching a query on the web or on World Wide Web, you are able to retrieve so many documents. What are the documents you are able to display on the ranked list of documents? The documents which are having more score, they will be displayed on the top, and that is the thought process that the high score, if the document gets a high score, this means that the system thinks that the document is good match for the query, whereas lower number means that the system thinks the document is poor match for the query, And if you are building the ranked list of documents, to build a ranked list of results, the documents are sorted by score, so that the highest score documents come first, scoring documents comes first. So here this is about abstract model of ranking. Whenever I would like to give the brief information about this topic, you will try to understand it in a very detailed manner here. Now I would like to explain about abstract model of ranking. As part of the abstract model of the ranking, in the left hand side of this figure consisting of a document, it is indicating the document, and here if you observe there are two types of the features are there. One is the topical features and another one is the quality features. Here the topical features are indicating these are all the different topical features are identified: fish, topical fish, seaweed and surfboards, and you will be having some of the words and like quality features, incoming links since last update. If you observe here, this document consisting of the language in natural language that is not understandable by the computer. Whenever you see that if the computer is able to understand the document, it is going to convert the document into the index terms or the features. It is going to convert into the index terms or the features. So that's what we are calling them as the document features. Majorly there are two types of document features are there. One is the topical features and another one is the quality features. The topical features are indicating the related information about the particular document subject, and the quality features are indicating how qualitative these documents are, and that is about how many incoming links for the document. So how many incoming links for the document from the different web pages, and since how many days back these pages are updated. Since how many days back these pages are updated, right? So this is about incoming links days since last update. This is about the quality features. So whenever the computer is converting into the index terms or the document features, so these features, topical features and quality features, are assigned with some numerical values. So this will be done with the feature function. This will be done with the feature function. So we can simply understand the feature function is the mathematical expression, simple mathematical expression that expresses the value in a numerical value, that expresses the value in the numerical format. And if you observe here is the ranking function, and this ranking function is going to combine the document features, and it is going to take the query given by the user and it is going to generate the final document score. It is going to generate the final document score. As we already know that the documents which are assigned with the highest score, and they will be most probably related document for the query, and the documents with the lowest score, so they will be less related with the query. This is about abstract model of ranking. And if you see the continuation for the abstract model of the ranking, you are able to find one of the more concrete model. What it is indicating, if you observe here is one of the mathematical expression is here, or of q comma d equals to summation of I gi of q and fi of d, where if you observe what is fi and what is gi, fi is the document feature function. It talks about the documents related information, and gi is the query feature function. So as we already seen about the feature functions in the previous model, that's about two types of features, topical features and the quality features. So that is indicating fi. So fi is indicating from the document feature function, and gi is the query feature function. If you observe here, as part of the abstract ranking model, we already seen that it is a document. From the document, number of document features or index terms are identified. So the number of document features or index terms as follows. So they will be represented with the fi. So here fish, topical fish, so different words you are able to identify as the topical features. And incoming links and update links, these two are the quality features, and they are assigned with some of the numerical values which are assigned with the feature function. So we already know that a feature function is nothing but the mathematical expression, simple mathematical expression for expressing the numerical values. So this is from the document and it will be processed. And if you observe here is a query. So the query is topical fish. So in the same manner, how you are going to calculate the features from the document, here is also from the query side also we are going to calculate the features. So both the features will be calculated, topical features and also the quality features. Topical features will be calculated and quality features will also be calculated. So here the topical features and quality features we are representing as a query feature function as a gi, and document feature function we are representing it as a fi. And if you see in a more elaborated manner, so here observe, we assume ranking function R. ranking function takes the following form, as the ranking function R of q comma d equals to summation of I gi of q fi of d. So this is from the document end and this is from the query end. So this is from the document and this is from the query end. Here if you observe, fi is some feature function. Fi is some feature function that extracts a number from the document text. So what is fi here? Fi is some feature function that extracts a number from the document text. Gi is a similar feature function. That extracts a value from the query. These two functions form a pair of feature functions. So these two functions are going to form a pair of feature functions as follows. So as like this it is going to form. So each pair of functions is multiplied together. So here each and every pair is multiplied together and results from all the pairs are added to create a final document score. If you understand here, so fi is some feature function that extracts a number from the document text. So from the document text you are extracting a number, and that is about fi is some feature function, and gi is a similar feature function that extracts a value from the query. Next, these two functions form a pair of feature functions. Each pair of function is multiplied together. And the results from all pairs are added to create a final document score. If you observe here, this is what I am talking about. So for example, here you are going to find this term gi and fi. For the terms you are going to multiply, and like that for each and every pair you can multiply. So the tropical and tropical fish, so the next word seaweed, surfboards, and you will consider all the words, how many incoming links, updated count. So these are all the pairs as you are going to multiply, and finally you are going to add each and everything. Finally the document score will be this one. Like that for each and every document we are going to calculate. Calculate the document score for each and every document. So this is about more concrete model. As part of abstract ranking model, so we come to know that how we are going to generate the document score in general, and as we see and try to understand the example here from the more concrete ranking model, how the document is processed and how the query will be processed and how the values are assigned, how the document score will be analyzed. So if you observe here, this is the more concrete ranking model. Fi is the document feature function and gi is the query feature function. Where you will be having a document here, and whenever you will be having the document is processed and the document features are identified. So the document features are identified as one is the topical features and another one is the quality features. Topical features about the subject of the document, and the quality features indicating how the quality of the document it is. And from the query end also the same process will be repeated. So the topical features and the quality features are identified, and each pair of the documents are going to be multiplied, and all the pairs will be added for finding the final document score. So with this I am concluding this topic. Thank you one and all.